some basic things about helping each other, please do. Yeah. If you are stuck with something and you don't know, and I'm helping somebody else, just ask each other like, did you already solve this? And then there are like some minimal, reasonable guidelines. You shouldn't touch the other person's computer. So that's really not a good way to help him or her. And so you just you just speak, yeah. And then also, if the person is like slower than you, don't like actively help the person. Just let the person go on its own pace, and that's it. What happened?
So I'm trying to run it, and it says that it's running, but actually it doesn't. Or I have to change something first.
Did you build? Yeah, but it does that automatically. That's really weird. But normally, if you do, can you do Cabal build, and then it should give you.
I did a new build.
Yeah, just build, and then it gives you where it is normally. Can you do dot slash to just dot slash to execute it immediately, and then it should be in dist build, and then there should be snake, and then snake.
I think we need to define the directions.
Well, probably you edited some parts, and it basically just crashes at this point. But I find it strange that you don't get an error message. Normal is this you didn't change anything to the file yet? That's a bit strange.
And am I supposed to work on exercises or modify project?
Well, so the file is under main, so you just have this. So it's under source main. That's where all the and so I recommend you to basically read all the comments that I wrote until you reach the exercises. Yeah.
So first this and then exercises, right?
Yeah. So the point is that the first exercise online is in box.
I already completed 3 of them. So
yeah. So but they are also in here, and so you can just then copy paste your solution in here, and at the end there are some more exercises in here than there are online. But if you solve all of them, normally you should have a running snake. No, but you can, in the test also, you can ignore the empty case.
You can ignore the empty case. Yeah, but should we design that, or is it just out of scope for?
Well, it's the test. Well, actually, you should take it into account, right? Yeah. It should give you a maybe snake, but that like makes it a bit more complex because that's like infecting the rest of your program. Yeah. And so then, in order to do that, you should basically use a monadic style. And I didn't explain that, and so.
I also am not familiar with it.
So for now, you can ignore it. And with a side note. Actually, that's not super. That's a little bit dirty. But let's make something working first, and then make it cleaner. Did this work for you?
Yeah, actually.
Okay, great.
Okay, so let's.
Hello.
I define extend, then I can directly pattern match.
Yeah.
Yes.
Yeah. And then
If I run it,
what does it say? No, I think you are pattern matching wrong. The point is that what you are pattern matching is you pattern match on a list which in itself contains a list with a head element X, Y, and then the rest. So these braces around it put your list in another list, which is not the thing. So you need to remove these
tried
ones.
that.
Yeah, but I think then you
Then
probably.
you get another error, right?
Yeah, so if you put those ones in parentheses, it probably will work. Because it probably thinks that the other argument.
But how does it differentiate between tuple just with the comma?
What?
Round braces are also the tuple.
Wait. Yeah. So wait.
So it just looks for the comma if it's to determine to look if it's a tuple.
Wait. And then so that's probably going to work. But let me see. Maybe I didn't look at your body, the body of the function. No. Let it run.
It's taking longer.
Yeah.
It's a good sign.
I don't know if it's yay! High five. And so there are still some small hints that I want to give you. Use the .i if you don't know something. You can just ask Haskell and it's going to give you some documentation about it. And then there is something super cool which is called Google. And if my internet connection would work, you would go to something which looks like Google, and then you can search for functions based on their type in Haskell. So I hope your internet works. Cool.
You can go back and do it. We'll stop.
It's so weird. Yeah, there are 66.
It's really mad.
Like he's having a problem with
Wait.
pattern matching here. And,
Okay.
so what I think is happening here is that it's wrong. Is that like this? It
no,
evaluates
you
to
can-
a boolean and then an integer, right?
You cannot do that at that
Yeah.
point.
You would use guards, right?
Yeah, you can use a guard for that. So you can do inbox x, and then you can write a guard, which is with like this pipe symbol.
So inwards, X, Y.
No.
You would first you would have a space
write the parentheses?
Second. They are really not. How do I say this? Like helper friendly. So, well, yeah. Indeed, you can do in, but you wrote there is a typo there.
Yes, yes.
So inbox.
Yeah.
Yeah. No, the B has to be removed. And so I wouldn't recommend you to write it like this, because now it seems like a function call or something in another language. So put a space between the X and the thing that you're pattern matching on. No,
The inbox.
after the X.
After the X.
Yeah. From inbox.
Okay. Yeah.
Yeah, so.
And then,
And then
you need a
you
comma.
need a comma, because you're basically saying I'm going to pattern match on.
No, in the tuple.
Okay, here.
No, so inbox space and then the parentheses. Yeah, XY. And then you can pattern match. Now you can make a guard. So it's the pipeline symbol. And then you can put a condition, for example, that X is smaller than 0. And then you write equal. And you then, for example, you write false. And then you do enter. And then you only have to write the pipeline symbol again. And usually you put it underneath the other one. Yeah. And then you can say X is bigger than, or all the rest. And it follows the same pattern.
Yeah.
It's going to work for you now. Just try it, and if it doesn't work, you can call me again. Oi, sorry.
If I can just ask no idea how.
So it means that it failed, and it's 17 passed, and then it found out that the smallest thing that to pass is when it's 0, 0. So if you
The snake is 0,
can
0,
I look at the code?
direction is 0, 0.
with 0, 0 gives you snake, and then you do so the first and the second, that's nice that you use this, but you can do this quite a lot shorter by using pattern matching, but that's not a problem. This is no, this should give 0, 0, 0, 0, but
It should be this line actually.
Yeah. So can you go back and remove this one, this 0, 0, extend in the
This one?
work, because I basically even if you don't move, you still extend. And so what you did is you don't extend the snake when it's 0, 0. It's basically like extending it but not moving it.
Oh.
And so it's really a corner case in the sense that all the directions that we are going to use are not 0. And so I didn't, in my unit test, when it's 0, 0, I still add the same position to the front. And so actually your solution was better, I think, to take this into account when it's 0, 0, that you don't actually extend the snake.
To do it with pattern matching?
You don't have to, but if you do it, then you can just write extend and then a tuple, so you just write, for example, H for the head of the list, then the double colon, and then you have the rest of the list. No, double colon,
Oh, double colon.
and then the rest of the list. No, one. And it's a double colon. That's a upton. Yeah.
Double colon, yeah.
It's only one.
Wait, one.
One double colon. Yeah, so
That's
that's
a
the,
colon.
yeah. And so then the rest.
And the rest.
That's the, so what you do is your pattern match the head and the rest of the list. And so you can also pattern match on the head by writing instead of H tuple X, comma Y.
Yeah, but so the direction is always the new coordinate. It's not something we are supposed to add.
Yeah, no. You need to add it, indeed.
And H.
So now write, instead of H, you can write X, comma Y.
Okay.
So that's the, but you need to put it in parentheses. X, comma Y. So now we have the head coordinate. You you can then pattern match on D1 and D2, for example, which you put in a pair, so parentheses. So this is the first argument.
The first argument.
That's the snake. And then the second argument.
So wait, I should put snake like this?
No.
Sorry, equal.
So you're pattern matching the snake, and that's going to deconstruct your snake into the head
okay. So
and the rest of the snake.
Yes. So this is the construction.
And then you can deconstruct the direction. The things, so then you don't need to use the first and the second and so on.
Yeah.
Yeah. Okay. I will be shortly.
I guess I faced a couple of problem. So I tried to generate a random number, and it says that I guess it's a conflict with
So
native.
the problem is that if you try to run this file while there are still undefineds in it, it's not going to run it, because it's basically going to say that there is a problem.
I just tried to do like this.
Okay.
No,
But I think that it's because you need to not use next. So can you do double colon T on next? So it says it takes G and it so make std. And so what is it saying? Undefined symbol. And what's seed? Does it know
See,
seed?
that's 42.
Okay, that's a bit strange, because yeah, it should give next. That's strange, and it says undefined gloss, but it's really weird because I don't understand because this. Wait a second. Is it just because it doesn't? Can you do import? Import system dot. No, with a capital. System dot random. And then execute it. No, it's not that.
I guess I need to uninstall something that Haskell installed globally.
That's really weird. I will come back to you in a minute when I try it out on my machine. You should be able to continue with the exercise online. And I think you're on the right direction, so I'm coming back immediately. Okay, so you all had the same question?
Yeah. No, actually, I had a real bug. I don't know what. Yeah.
So this the test here expects a let in. I use the where clause to get the variables in. That changes the order, I think, of evaluation, and the test fail. Even though I'm getting sort of valid ranges for the numbers, it's not getting the numbers that it expects. So I can. Oh, sorry. I'll go to one of these. Oh yeah, there. This kind of thing as well.
So that's because you are probably.
Yes, I think the where clause with the execution order changing versus let in.
Snake collides with a. Yeah, because the tests check for exact number and not a valid range.
Well, not exactly. Could it be because I pass in a random generator which has an initial seed, and so then you get a new X. Let me look at my solution, and then
Do you want to this example to you?
it's kind of in my head now, but.
Okay, yeah, I can see the argument for let clause.
So I think I have exactly the same. No, I use random, and you use next. That's the difference. Okay, so that's why. Okay. Yeah, as I put like as a hint, look up random, but in the next apple. My test kind of assumes that you use random. Yeah? So you can also use next, but it's going to give you different kind of random numbers because you use a different kind of function to generate a next random number, and so the test is probably it's definitely going to tell you that it's wrong, while it's a reasonable solution. So if you run into that problem that you use next instead of random, don't worry. It's correct. If you change the code to use random, it will give you the same solution as the one that I coded. Okay. So snake move. So who is now at snake move? Who is now solving snake move? Well, it's a bit strange. There should be people working on this because look, 21 users of the 21 have solved this one already. That's great. So some people should be on move, right? And it's strange.
I know, that's why I was like trying to search what can you do with it, but I could not find it.
Let me take my system, because on mine it is. Yeah, of course.
I mean, if I do an info on STD, then it doesn't say anything. Okay.
No.
For you, it's there. For me, it's not. So either I just need to upgrade GAC.
That's yeah. I didn't. So.
Let me see if it works.
What but you still need to have some kind of way. It's probably test is not going to pass, but you can probably see random of this STD thing that you got. I think.
It was just so confusing to not get. Where is it? Okay, fair enough.
So which version are you running?
Let's see. 802.
Yeah. So that's yeah, we are at 8.4.12 or 13. So, but it's fine. The only thing that is going to change is the monotype class has changed, and
Theory is really old.
yeah.
What comes with the
But I think you will probably be fine for what we are doing. Okay, so a small disclaimer. So if you get to Snake collides with Apple, you need kind of the functions that you have previously defined, right? I didn't want to make it too easy but there is this import helper, yeah, in which I give like example solutions for all these functions, but you cannot see them. Right, so you import them, and I list here all the things that you can use. And so it's kind of the idea that you make use of these things. So instead of writing 64 in your code, you should use width and height and so on. So just that you know that although the definitions are not here, they are in helper. And from the next exercises on, this is the case. Okay. Okay. So the problem is that you just generate a random number, but you need to bind it within a certain range. And so you know the modulo operator? So you can use that one. So it's mod in Haskell.
Maybe the random generator is bound already. But it's not.
And so you're using next, it's going to give different results. If you use random, it's going to give the same as my unit test. There are no dumb questions.
What? I don't know. Okay, so I'm looking at the step function. Initially I had this, where you're saying take step of delta time, and the world itself is storing, I think, the absolute time.
Yeah, so you're going to get the time, it's a float, and I think it's in what is it, in milliseconds, I think?
Oh,
and so, no, it's just a float, and no, it's like parts of seconds. It's in seconds, and so you're going, if you do 4, it's going to be 0.25 every time, if you have a refresh rate of 4, and so you need to give like the next time. So you need to keep track of this time yourself, because the only thing that you get when you, from Gloss is like the time that has passed between the previous time and now.
Right.
And so you need to like add this yourself.
Okay, so I'm marking that as delta, like dt here, like just delta
Yeah.
time. If I destructure my world, am I storing the absolute time in my world since the beginning of the simulation?
So what in our case, yes, we are just adding all this time, and so we are doing this until we reach 1, and then we reset it.
Okay, that makes sense. This is a sort of like fractional time in the last second, and then as soon as it goes past it, we just lop off, and then we store that fraction.
Yeah.
Okay, cool. That's perfect. Thank you.
So it's actually, you couldn't know that, right? So it's very good that you asked this question. So Gloss calls your function. The Gloss will eventually in the code you will call this step, and so every time step is called, it's going to give like the delta with the previous time that the step function was called. So it's not absolute time. It's like the time between the two step calls. And so in the world we kind of keep the absolute time. And so you should increment that time yourself, so that when you reach over a second, over 1, then you extend the snake. That's how I implemented the logic. So every second you extend the snake a little bit, so that it becomes more difficult.
And also we zero out the time we stored, right?
You should still move if it's. You should still move the snake if it's not above 1 second. You see? So you move every time you get an update. Yeah. But if it's over 1 second, you actually extend the snake. So there is like 25 times.
When you say move, you mean change direction?
Well, really move the snake. So there was a function move. So you should move the snake every time the step is called.
It might move more frequently than once per second.
Yes. So it actually moves every time you call step, and if it's over 1 second, you extend the snake, so that it becomes longer.
So then does the extend only when you eat the apple or something?
That's the way I implement it. Sorry, if
Snake rules, okay. That's the part I wasn't clear about.
Sorry.
We need to sync to a frame rate. The second frame only move, like, right, not rely on the frequency that the system calls us.
Well,
Update only after we
so I'm sorry then for the explanation. So the idea is,
basically every second that passes.
yeah, every second you extend the snake a bit with 1, and then every time the step function is called, you move it.
And what happens when you eat the apple?
When you eat the apple, you need to create a new apple. You just move it. In this version, there is no score being kept, but it's a very good first extension to make, of course.
Take pride.
Okay. Maybe I got this question now a couple of times. So could you wait a minute? So I got this question now a couple of times. If you reach the snake next world and step, it might not be so intuitive how the snake game works. So there are 2 important things. One is when you get this step, this float, yeah, that's like the time that has passed since this step function was last called. Yeah, and so basically with this step we want to do 2 things. We want to extend the snake if more than 1 second of absolute time has passed. And so in the world we keep track of our time. And so here, for example, we will get 0.25 seconds, 0.25. You're not going to get the absolute time. And so that's why you need to keep the time in the world itself, right? Everybody's following what I'm saying? Then the second thing is apparently this is not the way that the normal snake game works, but I extend the snake after every second. Yeah, so not when it eats the apple, it's being extended after every second. So in this step function, you should extend the snake after every second, and otherwise move it. Yeah, so extend means that the snake actually becomes one bigger, and moving means that you actually just move the whole snake in the direction which is indicated by your world. Okay? Shoot.
I want to understand how Apple works here. So Apple is coordinate and standard generator which was created somewhere else, and I need to give it like minimal value, maximal value as a tuple, and give it the generator to work, right?
Yeah. So what you could do, well, maybe you can look up random, because that's also the way that the unit test is implemented. So if you call random, it gives you need to give it like one of these generators, and it gives you a new value and a G. The problem is if you just call random, it's going to give you a very big number. possibly. And so you need to still make that this number is within the range that you want it, right? So you can use the modulo operator for that.
So model and no random range.
What?
Not random range, but just try to do it.
I'm pretty sure you could get also if you use the other ones, but it's just that the unit test is implemented with random, and so otherwise you will not get that it's correct because probably other kind of numbers are being generated. But this actually shows that you have a type error.
I don't understand the type error.
Okay. So random R. Can you go back to the documentation of random R?
Sorry.
So let's look at random R. The thing is that you give it two coordinates, A. So you give it an interval, right? And then a generator, and gives you a number which is inside. So let's go back to your solution. So in this case, you do 0 till width, and you give it G, and then you create a second thing, which is G, and then you give it a G.
G to get the type.
Yeah, so then you should get a coordinate. Okay, can I look at the feedback?
I can run it once more.
No, it's fine. If you
just a second, because maybe I changed something.
Okay. Okay. So wait, then we get couldn't match expected type int with int std gen. And
so should I give it as a tuple here? No, expected type.
Can you show random R again, just to be sure? So it takes a tuple, a G. So the problem is it's not only giving an A back, it's giving an A and a new G. So in case here, you could take the first or something. So if you take the first of these two, it's going to still not give what you want, because it's probably going to pass, but the random generator that you're giving back is the original random generator. And so it's functional, and so if you use the same random number generator, it's always going to give you the same number. So you want to really create a new random generator to get a new random number. And so your solution is wrong in that respect. But if you now make a new random generator, well, you could, but that's always again going to give you back the same one. But what would help is that you call this and then you take the second one, right? That's going to give you a random generator, but it's a very dirty solution.
Okay, and there isn't a way to generate a new number generator in Haskell easily?
Yeah, but yes, you get it like this. But the point is that by using this random R's, you get like you basically the easiest way is to use this where thing, because you also want to use another random generator for your second number, right? Yes. And so you basically create a new random generator and you use that new one for creating the second number, which gives you again a new random generator, which is the one that you pass to for the rest of your program.
Okay, I understand.
Cool.
I think for future you can add something about the number generators here, because like I've checked that and there are so
yeah, that's exactly what I was saying.
I can reference.
So
goes in sequence.
Yes, that's what you could do, and it's just a matter of style. But usually you put this where in front, but it's it's fine. I mean, Haskell is not complaining about that, I think, and there is no comma between your where clauses.
And how?
And so normally you also put it tilde so that it's on the same height. No. So you do the enter, but then you align your x and your y like that. Yeah, that's usually how you do it. So I think this should, yeah. And so that the next, if you now constrain it, it's going to work. But the unit test is going to give that it generated different numbers because I used random instead of next. And so, but if you just change next for random, yeah. And then the other thing, which is a bit strange, is that you're using these parentheses, yeah. And that kind of looks like that you are programming in Java, and that this is like. Yeah. Yeah. So already thank you everybody for coming. We will finish. So tomorrow we will. I will show like a solution to the exercises, and then the second part that then I'm going to give you the data structures that you can use for implementing Tetris, and then you can also implement Tetris, and there's going to be two ways to do it. One is where you basically just get the data structures, and one is where you also get like the skeleton code just like today. And the reason is, if you feel confident, oh wow, I already got this snake nailed down, it's super simple, then you can actually try to use the same kind of style to implement Tetris. And so if you are very confident about implementing snake, and then do the exercise of with the skeleton code, I think tomorrow you will probably be done in an hour. Or even less. So if you think that you're in that situation, I recommend you to do it from scratch, and then you will probably need it 3 hours because you have to think about the design yourself.